My lab has two arms. One arm is focused on understanding how pancreas cancer spreads to other organs, particularly the liver. And we focus on that because, first off, a lot of patients with pancreas cancer, their disease does spread to the liver. And once it gets to the liver, it's very, very difficult to treat. There's extremely limited treatment options available for them. And usually the benefit of those therapies that are available is very minimal. So we really want to understand how that process happens to be able to block it before it even occurs. The second arm of my lab is focusing on how breast cancer initiation occurs. And we've been focusing on how damage to the normal mammary epithelium is what it's called, or the cells that make up the mammary duct that is the cell of origin for breast cancer. How damage to those normal cells kind of leave those cells more susceptible to tumor initiation and therefore may be the driver of breast cancer incidence. Even though they seem like very different topics, there's actually a lot of overlap in terms of the tools that we use to study them and the kind of the thought process we approach. So both, I think it's just a phenomenal program. I think that it's very difficult for students early in their career to find opportunities to participate in biomedical research and in academic lab spaces. Part of my job is supporting the next generation of scientists and really raising them up to ensure that science continues. I aspire to eventually find a target that'll go to the clinic and help patients. But if I fail to do so, at the very least, maybe I have, essentially trained the next generation that'll find those targets that'll help patients. There's so much data that increased diversity brings increased insight and increased progress. And so without diversity, progress is slowed, and that has been shown over and over and over again. So, programs like this are so critical for continuing to bring people into the sciences that may not have had the opportunities. Yeah, Parnian, I number one, she's just like universally adored in my lab. So she's just a joy to work with all the time. She's just like, and in that regard, she's incredibly resilient. She is almost unfazed by failure in a way that's just like, all right, this happened, let's figure out how to tackle that. And that is really what makes the best scientists, are people who fail quickly and then adjust what they do moving forward. The urep program, which is the UW Milwaukee undergraduate research program, is a program that's intended to give students at UW Milwaukee an opportunity to come into academic labs here at MCW, and specifically students who are representative of underrepresented groups and maybe haven't had the opportunity to get into science yet. A lot of students that haven't had experience in labs yet, of course, there's a very significant lack of confidence, which is totally understandable. It takes a while to understand that failure is so normal that we all fail. We all fail all the time. And that's fine. You just learn from that failure, you make changes to what you're doing, and then you move forward. But she was training under my postdoc, Priyanka Jayakrishnan, and Priyanka is just a stellar mentor, just always supportive and positive and very good teacher. And I think they really bonded, and they're just like almost the best of friends at this point. So very, very nice to see that relationship, bud.
I'm originally from Iran. I was raised there. I went to high school there. But when it came to university, I wanted to study med school, and I had no idea and no background on research. So I did not know if I could. I thought that I should really use the opportunity, but I didn't know if I could, or if I had the background to even be able to do research. And everyone is really helpful. It is so exciting. I still get excited when I do the most basic things. Like cell splitting is something I think everyone does, but I still get super excited. It's crazy that I get to do this like every time I come to lab, and a lot of the experiments I've never done. So having to figure out how to do it is stressful at times because I want to make sure I do my best, but also really exciting when I start getting it right and I know how to do it. Oh, it's It's the best feeling ever. I'm so excited that I'm here. I have no idea. So having that opportunity to see different cultures and different people and see how incredible everyone is, it's fantastic. Our postdoc, she came from India and she's so incredibly knowledgeable, and being able to learn what she learned in her PhD back there, it's amazing. I know pancreatic cancer is the third leading cause of cancer deaths in the United States, and as with most cancer-related deaths, the cause of death isn't really the cancer itself; it's the metastasis, and the microenvironment of the tumor has been shown to be like a major, determinant the progression of the cancer. And the microenvironment of the tumor is anything that is surrounding the tumor. So it could be blood vessels. I generally think that science is pretty cool. It's like solving a puzzle, and I knew I wanted to do something in sciences. I was leaning towards med school, but having the opportunity of doing research really solidified it for me. The classes that we took, they helped us a ton in figuring out how to write grants, because I'd never written anything at all like similar to a grant. So they helped us a lot, and the connections that we made and being able to be an MCW and do research, it is all through the urep program. I think in my 4 years of being here, this was one of the most incredible opportunities that I could have had, and I'm so thankful that I got the push to apply and be here right now. Dr. Lytle is an amazing mentor. I think I got very lucky. Of course, all PIs are amazing, but my PI, she is so sweet and kind. She's so knowledgeable, and I think a big determinant of how knowledgeable someone is being able to bring it down for like any level to explain, and being able to explain like something to the postdoc and then something to me is not easy work. But she makes makes the science so I don't know what the right word for it would be, so accessible, um, and not scary, which I think is super important. I think I really want to make sure that I implement clinical research in my future career. I want to be able to help with like the treatment protocols, with new drugs that came out, with different trials. And I used to say that I'm never going to do oncology, but I think that's the specialty that I'm most interested in right now. I think potentially I do see myself doing oncology as a specialty. I do if I bring it one step closer to someone else finding a cure, or having someone else be diagnosed and not be afraid of losing their lives. I think that's good enough for me.
So we do very generally, we develop statistical methods to analyze, large data sets. My research focuses on analyzing genetic data sets. Um, and so at a high level, we're basically accessing huge databases of genetic information and trying to understand how that can lead to new insights into how cancer progresses, um, the chances of survival when somebody does have cancer, and the risk that somebody gets cancer in the first place. I decided to become a mentor because I think it's important um, for undergrads to have exposure to research opportunities like this. If we're gonna continue on as a field, we've got to get the young people involved at an early stage and get them excited and involved in research opportunities. No, I did not. I didn't have research opportunities until I was well into grad school. I think that having access to something like this would have certainly accelerated my development as a scientist. I would have gotten, I think, where I was headed a lot earlier in my career if I had opportunities like this, certainly as an undergrad. But again, I didn't have access to something like this. And it's not entirely clear, the research process to people that aren't actually involved in it. When you first enter the sort of a research lab and you get involved in research, you don't really know how it works. From the very beginning, from conceiving of a research project to actually executing it, and then publishing results and disseminating results and presenting on it. That will typically take many years, uh, requires quite a bit of patience, quite a bit of persistence. And if you haven't done something like that before, you really have no idea how it works. Um, so I think that that's a big part of it, is just sort of learning how the research process really works, and just she's a very very quick learner. For instance, I don't think she had hardly any experience coding before she came into the lab, and since then she basically self-taught coding in a number of different platforms and is now quite proficient at it. So I mean, that I think that's just sort of demonstrates a lot of her sort of self motivation and capabilities. It's because I mean, if you think about women and minorities as an entire group, that's much larger than non-women, non-minorities. And so if that's that's most of the talent that exists actually. And so if we're not supporting them, then we're ignoring the majority of the talent in the population, which is obviously silly and sort of self-defeating. So I think this is critical if we're going to have the next generation of scientists and researchers who are going to push everything forward. You've got to look across the whole population for the most talented people. You know, our research lab, we're always working on a bunch of different projects at the same time. It's kind of a very exciting situation. We have, because we're working on many different projects, we're seeing results all the time. We're, observing new discoveries every few weeks probably. So it's kind of it's a very exciting, very sort of vibrant intellectual community. And if that's something that appeals to an undergrad, if they want to be part of that, if they want to again learn the ropes and see how things operate in a research lab, particularly computationally, that's what we do here in my lab. Then this would be a good fit. One thing in particular that we're working on is we're developing new tools for how to detect somatic mutations in the blood that exist at very, very low levels that would give rise to different, essentially blood cancers. If we can drive that lower detection limit even lower and lower and lower, then we're going to be able to identify people who have these pre-malignant mutations really early on, so we could push them forward to screening and observation and so forth, and potentially early treatment. And we make progress on this tool very regularly, and so we're able to see huge gains, compared to existing tools. And that's quite exciting because once this goes out in the public and the public domain and people actually start using the tool, we think it'll be hugely beneficial for detecting these sort of subclinical cancers, and for, again, early detection and screening. Kaylee helped analyze a huge database called the All of Us Research Program, which is about genetic data on 500,000 people with plans to get data from 1 million people. And she actually helped analyze that data set using these tools, and was able to characterize the prevalence of those mutations in that data set of about 500,000 individuals, which are linked to their medical records, so we could then determine who developed cancer, who was cancer free. So she was key to that implementation of the algorithm on a huge scale.
My name is Callie Quaid, and I'm a senior at UW Milwaukee. Starting at UWM, yes, but it was a journey to get to that point. Throughout most of high school, I want to say, I was kind of dead set on engineering, and it wasn't until like junior year that I was taking biology and chemistry together, and I kind of put two and two together that I found it really fascinating, and specifically with regards to like, human body systems. And so entering undergrad, I decided to major in biochemistry to put those topics together. And then starting research, I wanted to introduce sort of like the math classes that I really enjoyed. And so that kind of landed in like data science. I think mine is a special case because it's in data science. It's very math heavy, very statistics related. And so in that sense, I think it's very similar. Sure. I've had family members who have had cancer, and it's really had an impact on me seeing how their disease progressed and their treatment and what they went through. And I really felt like I wanted to make an impact as much as I could. And I think this program specifically has helped me make the most impact I could as an undergrad. That's actually a funny story because I wasn't planning on going into data science specifically at the beginning. I was more so leaning towards like biochemistry, like my major. But then I found myself really missing my math classes that I had previously taken in like high school. And so I voiced that to the program director at the time, and she said she knew a person that she think I would get along with, and we did. We really hit it off, and he's been a great support since. And he's a great teacher too, because he's taught even before working at the cancer center. So he's really patient and takes the time to like show me all of like the biology and whatnot to me. Currently, what we're working on is called a genome-wide association study, or a GWAS, and we're using the All of Us research program, which is a NIH-funded program that people are allowed to voluntarily give their like genomic data, or I guess biospecimen data, EHR data, survey data, etc. And we are able to, as researchers, use that to conduct analyses. And the one I'm specifically doing is taking blood pressure data as well as genomic data and finding kind of spots in the genome that leave you more at risk for developing high blood pressure. Okay. I was in the program around 1 year, and then since then I've been hired on as an employee. I've been able to attend many conferences and give presentations at symposiums and even participate in manuscript writing and editing, which has been really a neat experience. Yeah, I plan on applying to medical school in the spring, and with that, I'd like to continue doing research in whatever capacity that allows. And I've had many meetings with incredible people and been able to see pretty amazing keynote speakers at conferences. One big thing that I did gain from this experience is that in those meetings, I met other researchers who are also physicians. And so that's kind of my path. So I've been really honored to be able to shadow them and see what my future kind of looks like. I would tell them it's very helpful in developing science communication skills, probably at the top, because the whole writing the proposal time, you're reading scientific literature. That was my first exposure to that. And then trying to put it into your own words and developing that has been kind of crucial. And then the same thing in symposiums, you're trying to talk to people of varying levels and learning how to accommodate that has been a great feat.